And how much is x minus 9 plus 9?
X,
What do we conclude?
they are inverse.
They are inverses of each other. I still have to find g comp f of x, but if this one is x, and I did not make any error, the other one must be x. Yes, please.
And that's my sound effect too, but okay, so we're just replacing the F, right? From
So
the cat.
we are
So, no,
replacing,
let me
go ahead,
okay.
yes.
So just the way I
Yes,
understand.
yes.
So that means that the 4x plus 9,
Correct.
we just want to take the, well, that it becomes, the x becomes the g, right?
Exactly. X minus 9 over 4. Exactly.
All right.
Exactly.
Okay. Okay.
Very good. So then we have to write, therefore, f and g are or are not inverses of each other. Are inverses of each other. Please choose one of these two functions because I would like to show you the procedure of finding the inverse. In this case, in this example, we were given f and g, and we established that they are inverses of each other. Choose either f or g, and let's find the inverse. Find the inverse function. 4-step procedure. Before you choose the function, let's talk about notation. The inverse function of f is denoted by f raised to -1 of x. Please do not read it as f raised to -1. Please understand it does not mean 1 over f of x. It does not. How do I read this? F inverse of x, which means the inverse function of f is f inverse. The inverse function of g will be g inverse, and so on and so forth. So please choose a function and let's work through the 4-step procedure. Or if you don't want any of these, I would like one of these so we can verify that it's the other one. But it doesn't matter to me, we can choose another. Okay, we want to find the inverse of f of x. Excellent. So find f inverse for f of x equals 4x plus 9. Step 1. Yes.
Is it the F in that means F inverse?
F inverse. It does not mean f raised to -1, and it does not mean 1 over f.
You can kind of just think about it. It's very.
It's just the name. That's the name of the function. That's the notation we use for f inverse. F inverse. So for example, if you look at your graphing calculators, so you see, for example, we don't have trigonometry in this class, but you see in blue sin raised to -1? That is a function. It does not mean 1 over sin. It means the inverse function of sin, sine. Good. So in step 1, we replace f of x by y. Now I'm going to ask you, will you allow me to do that? You can say, no, you can't. Or yes, they are the same. If they are the same, then you will say yes. If f of x and y are not the same, then you will not allow me to replace f of x by y. But they are the same. They're measured on the same y-axis. When we say f of x or we say y, we mean the same thing. So then y equals 4x plus 9. In step 2, we agree? No one said anything. Okay. Interchange x and y. Interchange x and y. And you can say, no, we've never done this before. Why would you even think of doing something like that? X and y are not the same. Because remember, x goes to y. But the inverse function is applied to this number that becomes x for f inverse. Let's illustrate this with the bubbles. So if I apply function f to 2, and let's say I get f of 2 to be 5, this is the y value for f. This is the x value for f. But now I want to go back with the function f inverse. What do I apply f inverse to? To 5. And what will I get? Definitely 2. That's what the inverse means. So if the function brings 5 to 2, the inverse will take 2 back to, that's the concept. Otherwise, I will not get x. If I get some other operation in there, I will not get x. That's the concept of the inverse function, right? If I apply f and then f inverse, the answer will be x. If I apply f inverse and then f, the answer still will be x. So that's the reason why this value, which was y for f, becomes x for f inverse. That's why I'm allowed to interchange them only in this situation when I determine the inverse function, of course. Okay, so then x equals 4y plus 9. In step 3, what do you think I'm going to solve for? What am I after? I'm after this eventually that becomes y for f inverse. So I will solve for y in step 3. Solve for y. Okay, how do I solve for y? Of course, I move 9 and divide by 4. So y equals x minus 9 divided by 4. It's a linear equation. I move 9 and divide by 4. So it will be x minus 9 equals 4y divided by 4, and I get this. In step 4, replace y by, what notation do I have to use now for y? Exactly, that's what I'm after. So now going back to the functions that we picked, what did you expect the inverse function to be? You absolutely expected x minus 9 over 4. Why? Because we already established that they are inverses of each other. So of course, when I calculate f inverse, I must get g. If I calculate g inverse, what do you think I'm going to get? 4x plus 9. Why? Because they are inverses of each other. It's like if I create a function for you, let's say function 1/3 x, what would be the inverse function? Let me write it because it's better to visualize it. So let's say I'm creating f of x as 1/3 x, and I'm asking you, please give me the f inverse if you can. Exactly. It's the same thing. I'm giving you 5 and I'm taking 5. I'm dividing by 3. What is the inverse operation of dividing by 3? Multiplying by 3. Do you want to check that they are inverses of each other? How would you do it? You will determine f comp f inverse. And what should the answer be before you even look? If the answer is not exactly plain x, nothing happened, right? I'm giving her 5, but now I take it back. If the answer is not plain x, these two are not inverses of each other. So f of f inverse. So this is f of, what is f inverse? 3x. And now I'm looking at f. F says 1/3 times whatever you want. But this is what I want now. I want 3x. So 1/3 times 3x. And the answer is? Of course. We knew that. Multiplication by 3 and division by 3 must be inverses of each other. Any questions for me?
And
Any questions?
I have a question.
Yes, please.
So the inverse of x being 3x.
There is no inverse for x.
I mean, isn't that what it's called? The inverse?
So these two are inverses of each other because f come g, or f come f inverse, or f inverse come f,
Inverse.
yes, will equal x.
So how's it 3 again? The inverse of x? I mean f.
No, I'm just giving you two functions and I claim one is the inverse of the other. So we just wanted to prove that.
Right, but
So-
but we told you that it was 3x, right? When you just wrote 1/3, like 1/3.
Yes, so I gave you 1/3 and you said, oh, the inverse function must be 3x. And now we want to show. We wanted to show.
How is it 3x?
I'm giving you $5, but I'm taking 10 back from you. Is addition by 5 and subtraction by 10, are they inverses of each other? No, because what you have in your pocket has changed.
How would you get 3x?
Because I'm explaining that addition by 5
I
and
wanna
subtract,
know.
I'm getting to that. Addition by 5 and subtraction by 10 are not inverses of each other. But addition by 5 and subtraction by 5 are inverses of each other. If I multiply the money you have in your pocket by 3, and then 5 minutes later I say, I'm going to divide it by 3, you're still not going to have any change.
I get there. I just
Oh.
want to know how you got 3x. I just want you to
How I got this?
1/3 is how the f. inverse of 3x.
Multiplication, division by 3 and multiplication by 3 are two inverse operations.
So it'd be 1/3 times 3.
3 over 1.
I mean, 1/3 times 3 over 1.
But you get rid of the 1. So,
Thank you. That's,
Sorry, I misunderstood. My apologies. Is this clear? Okay, let's look at, I still have a couple of minutes. Let's look at problem 56. Sorry about that. Is that clear now?
yeah, I get it.
We are given two tables, and they are -1, 1, 0, 4, 1, 5, 2, -1, -1, 0, 1, 1, 4, 2, +10, -1. And in 56, they want us to find G comp f of 0. G comp f of 0. Okay. Forget about the tables right now. Just tell me what to write. What does G comp f of 0 mean? It means G of, yes? Where do I start? Like always, with the inside. How much is f of 0? Very good. F of 0 is 4. So if this is 4, then I'm asked to find G of 4. Can anyone give us G of 4?
2.
Excellent. G of 4 is 2. Perfect. One more and then I'll stop. F inverse of G of 1. 58. Last one. F inverse of G of 1. Where do I start? Like always, with, good. How much is G of 1? Very good. G of 1 is 1. So now I want F inverse of 1. Forget about the tables. Let's think for a moment. Let's think in terms of bubbles. I have an X that goes to 1 because I want to apply F inverse to 1 and see what I get. And now I can look at the tables. So for x equals 1, y equals 5. So what should x be? So that when I apply f to it, I get 1. What value of x I apply f to get the y value to be 1? Exactly. -1. So now I'm asking you, how much is f inverse of 1? Exactly. Exactly. Any questions? Any questions? So we're going to have you